This lesson today is about scatter plots and looking at relationships between two kinds of data. In the last chapter we looked at one data set at a time, and now we're going to look at two data sets at a time and be able to compare them and look at their relationship between both of them. Okay? So the first vocabulary word you need to be familiar with is an association. I think you guys know if people are associated with each other, there's a relationship between people. So same thing in math. If we're looking at an association, that means there's a relationship between two different variables. It may be a cause and effect type of relationship. It may not be a cause and effect type of relationship. And we'll look at some different situations and examples of both. Another vocabulary word, the explanatory variable, is like the cause in a cause and effect relationship. It's the cause. Okay, the response variable is the effect. So it's what happens as a result of the cause. I'm going to give you some different situations, and for each situation I want you to tell me whether, first of all, there is an association or a relationship. If there is a relationship or an association, is it a cause and effect association? And if so, I want you to tell me what the explanatory variable is and what the response variable is. So that's kind of a lot to do in each one. Okay, but the first one, I'm looking at the circumference of an apple in inches and the weight of an apple in ounces. And so certainly probably the size or the circumference of an apple would definitely affect its weight. Probably the bigger the apple, the bigger the weight. Okay, so definitely I would say that there is an association for sure. Okay, and I would say that the circumference of the apple is the explanatory variable. And the weight of an apple, I'm going to change colors here so this isn't so confusing. The weight of the apple would be the response. And maybe what you want to do is underline one once and underline the other twice or something so that you don't have to make all these scribbles. But definitely association. The weight is, or the circumference is the explanatory, and the weight is the response. Okay? The next one, the number of miles that you've driven your car since you filled your gas tank, and the number of gallons of gas remaining in your tank. Okay, definitely a relationship. Clearly, the farther you drive, the amount of gas in your tank changes. Okay, so definitely an association. And then the explanatory variable in this case would be the miles that you've driven. That is what's causing the change in the tank in your gas, or gas in your tank, sorry. Okay, a few more. A college freshman's shoe size and his or her grade point average. And I don't think there's probably any correlation, any relationship between your shoe size and your grade point average. There's people with really small feet that are really smart, people with small feet that are not so smart, and vice versa, okay? Not a relationship at all. No association between your shoe size and your grade point average. So we are just done with that. That's all we have to do. Okay, if you're climbing a mountain, the altitude or the height and the temperature outside. And if you've ever been in a mountain, you know that the higher you get, the colder it gets, okay? So definitely a relationship, definitely an association. Certainly a cause and effect association here as well. Okay, definitely a cause and effect. In this case, the explanatory variable or the cause is the altitude or the height. And the response variable in this case is the temperature. Okay. Here, the temperature outside and the number of ice creams that are sold. Probably a relationship here. It might not be so strong, but there's definitely a relationship. Probably the hotter it is, the more likely you're to buy ice cream. And the colder it is, probably the less likely you are to buy ice cream. And that's probably very true in Minnesota versus other places in the country. But certainly an association or a relationship. And again, the explanatory variable in this case would be the temperature. And the response variable, what we're measuring, is the number of ice cream cones. Okay, Another one, the depth of a scuba diver and the visibility of the scuba diver. Um, Certainly a relationship here. Okay. And the depth is going to be the explanatory variable, and the visibility will be the response. Okay, so a cause and effect, it's a relationship and it's a cause and effect relationship as well. And the last one, the size of the desk and the number of desks that can fit into the room. Okay, definitely a relationship here. And is it in a cause and effect relationship? Yes, the desk size does cause a change in how many desks can fit in the room. Okay, so the explanatory would be the desk size. And the response would be the number of desks that fit. Okay. I should also tell you guys too, we looked at all cause and effect type of relationships in those examples, but there are relationships that are not cause and effect. Like if you look at the, and you've done this before probably, if you look at the relationship between your height and your arm span, there's definitely a relationship. Your height is about the same as your arm span typically, but it is not a cause and effect. One does not cause the other. Another one would be the relationship probably between your mom's age and your dad's age. If you look at that, women and men tend to date and marry and all that good stuff, people right around their own age, okay? Does does the woman's age cause a change in the man's age? No, but there's definitely a relationship, okay? So just so you know, they're not all cause and effect relationships, okay? All right, here are two examples of some different associations. And what we are going to look at now is scatter plots, which is a dot plot, kind of, where you're going to plot coordinates on an axis to be able to compare a relationship, okay? So the one on the left compares height and weight for people, and it's probably true that the taller you are, the more you're going to weigh. I think we all can agree on that. And you can kind of see what happens on that scatter plot and looking at some different points, okay? And then the one on the right is a scatter plot or a dot plot. It doesn't tell us what it's about, but it's definitely a coordinate. It's plotting coordinates, and it doesn't appear like they have much of a relationship. And we'll talk more about that in a minute, okay? So when we describe scatter plots or different associations, there's four things that we need to describe, okay? The first one is the form. And so the form can either be linear, if it's obviously starts to model a line, okay? Or it could be nonlinear, pretty much if it follows any other pattern. There's lots of patterns. In this class, we're going to just go for linear and nonlinear. We could start talking about parabolas and ellipses and boomerangs and radicals and all kinds of stuff. But for this class, if you were in AP, we'd do more. But for this class, we're going to just do linear and nonlinear and call it good. Okay, so it'll be linear if your dots are close to a line shape, and nonlinear if they're not. Okay. Then we need to look at direction. Direction kind of is like looking at the slope. So if your dots form what looks like a positive slope, just like when you were graphing lines, then the direction is positive. If it looks like it's a negative slope, then the direction is negative. Okay? The strength is the third thing that you need to talk about, and the strength is towards strong or towards weak. And again, it's not very often perfectly strong or really, really strong, and it's not always perfectly weak or really, really weak. It's kind of somewhere in between. Those words like strongly and moderately and fairly and all that good stuff kind of come into play here too, just like they did with the symmetry stuff, okay? But anyways, the one on the left has a pretty strong relationship, and the reason that is because your dots are all clustered right around a line. They're not in a perfect line, but they're clustered really, really close to the line of best fit, okay? So it has a strong relationship. The one on the right has a weaker relationship because your data is scattered a little farther away from that line. They don't all hug that line as closely, and so then you have a weaker relationship. And then the last thing you need to look for are outliers. So form, direction, strength, and outliers. And you're going to look for data that is way different than the rest. You don't have a hard rule like you did when you did box plots and some of those kinds of things where you did 1.5 times the IQR. So you don't have a hard rule, but you're going to just look for dots that kind of don't fit the pattern. In this case, this is an outlier and this is an outlier. So definitely ones that don't fit the pattern. Okay, so here's a scatter plot, and I just want to be able to have you give me the form, the direction, the strength, and talk about if there's any outliers or not. Okay, so on this one, I think you can see that the dots are sort of linear. They follow this pattern right here. I can draw a line. So this one, if I were to describe it, would be linear. It has negative slopes, so I'm going to do negative. The dots aren't super close clustered to a perfect line, but they're getting close, so I'm going to say moderately strong. And then I'm going to look for any outliers. And I don't have any outliers. If I had outliers, there'd be one like here or something that's not, doesn't fit the pattern. Okay? So linear, negative, moderately strong, and no outliers is how I would describe this distribution. I don't know what this scatter plot is about, or I would write a sentence about its, I would put it in context, okay? And here is another scatter plot that's got kind of a different relationship, but you can see that this is not linear. It's kind of boomerang shaped. So we're going to just call it nonlinear, okay? So this is definitely nonlinear. But my dots are still going in a positive direction. My slope would be positive. It's different as my slope changes as I go, but it's still growing. It's still going in the positive direction. I would say my relationship is fairly strong here, especially down here. My dots are really clustered towards the line. As you get up here, it's a little bit weaker. But I would say that my relationship is pretty strong. Okay. And then as I look at outliers, I'm just going to circle them on the graph so that you can see them. But there are some outliers, and I'm going to label them up here. I would say that this dot is probably an outlier, and this one is probably an outlier. And the rest of them seem to fit the pattern pretty closely. All right, and one more. Here we have a mess of dots that just don't seem to fit a pattern at all. We can't really draw a line in there. It doesn't look like it follows a nonlinear shape. It just is kind of a mess. And when you get a cluster of dots like this that are just really nothing more than a mess, then all you really have to write is no association. Okay? I can't even tell if it's linear. I can't tell how strong it is. None of that. There just doesn't seem to be a relationship between these two things. Okay. Now we're going to go back to those situations that we looked at the beginning, and we're going to just talk about if we were to plot these two things on a scatter plot, would we expect a positive association, a negative association, or no association at all? And then if there is a relationship, tell me what you think the strength of it would be. Are they pretty closely correlated or related, or not so much? Okay? And here's kind of what you do. You look at the two variables. In this case, again, we're looking at circumference and weight. And if they both grow the same direction, then they'll have positive association. If one goes up while the other goes down, then they'll have negative association. And of course, if they're not even related at all, there's no association. Okay? So here's what I want you to think about. As the circumference gets bigger, the weight also gets bigger. If the circumference was smaller, the weight would get smaller. So they grow the same directions, okay? And when they grow the same directions, that means they have positive slope. And I would say that there is a pretty strong correlation between how big an apple is and its weight. One might be juicier than the other and weigh a little more or whatever, but I'd say it's pretty close. I'd say it's a pretty strong relationship between the size of an apple and its weight. Okay. Here we go, the number of miles driven. So if you've driven more miles and the amount of gas in your tank. So if the more miles you drive, the amount of gas that you have left in your tank is going to go down. So here they grow opposite directions. One goes up while the other goes down, which means that there is a negative association. And again, I would say this is pretty strong. It's going to vary a little bit depending on whether you were traveling in town or on the highway in terms of how many miles per gallon you get. But certainly, the more you drive, the less gas you're going to have in your tank. So again, I would say that this is a fairly strong association. Okay, a college freshman shoe size and a grade point average. We already talked about that there is no relationship here. It would be one of those, if we were to make a scatter plot, it would be one of those clustered messes is what it would be. Okay, climbing the mountain. So as you go up in altitude, the temperature goes down. Okay, so again, this is negative. Okay, and this too is probably a somewhat strong relationship. Probably, you know, the higher you get, it definitely the colder it gets. And it probably jumps in kind of increments a little bit. It's not perfect. Like if you go up 5 feet, the temperature drops 1 degree or whatever. But it's going to be pretty close. So I would say, again, this is fairly strong. Okay, the next one, the temperature outside. So as the temperature goes up, as it gets hotter, the number of ice cream cones sold also goes up. So again, this is a positive association. But I'd say this is not really well correlated. There is a lot of people that like to eat a lot of ice cream in the winter and vice versa, okay? So I would say this is a pretty weak relationship. Okay? The depth of the scuba diver and the visibility. So as the scuba diver gets deeper, as their depth increases, the visibility should decrease because it's getting darker as you go down and not enough light is getting down there, so their visibility will decrease. Okay, so this is a negative association because they go opposite directions. And I would say this is pretty strong too. Okay, and the last one, the size of the desk. Clearly, as the size gets bigger, the number of desks that can fit in the room gets smaller. So again, this is negative. And this is very clear. This is a definite strong relationship. Clearly, there's not a whole lot else that fits how many desks that tells you how many desks can fit in a room besides the size of the desks. So this is definitely a strong relationship. Okay? All right. That is it for today's lesson, and we will see you next time.